Welcome back. In this video, we're going to prove that 2 arctangent 1/2 minus arctangent 1/7 is pi over 4. This result is extremely important because we can find an approximation of pi by using arctangent. And we can use the Taylor's series to find a good and a nice approximation to pi. Once we do that, we just multiply by 4 and we get pi. So here we're going to prove this result using pre-calculus. Okay, and I'm going to skip or I'm going to remind you of some of the results that I have proved before. So one key idea is that we have proved that the cosine of arctangent of x is 1 over the square root of 1 plus x squared. Also, the sine of the arctangent of x is x over the square root of 1 plus x squared. So here we can prove these results by just using the fact that if we let alpha the arctangent of x, and given that the arctangent is always between minus pi over 2 and pi over 2, we can take the tangent of alpha here and get x. Okay, and we can we know some of the rules, the cosine squared in terms of tangent and sine squared of tangent, and we can get the result that we need. But to solve this problem here, we first gonna use the fact that the arctangent is always between pi over 2 or between minus pi over 2 and pi over 2, and it's defined everywhere. So we can prove easily the following fact. We can prove that this one, using that the arctangent is an increasing function and it's always trapped between minus pi over 2 and pi over 2. We can prove that this one here, we can prove that 2 arctangent 1/2 minus arctangent 1/7 is between pi over 2 and 0. Okay, so this is a key idea that we're going to use later to find the exact value of this quality. Okay, so now we have all the tools that we need to solve this or to show this result, except that we're going to use the fact that here the cosine of 2 arctangent of x is, so using the fact that this is just 2 cosine squared of x minus 1, and we know the cosine squared is 2 over 1 plus x squared minus 1. Okay, the cosine of alpha, alpha is the arctangent of x. Okay, so this will give me 1 minus x squared over 1 plus x squared. And also the sine of 2 arctangent of x is just 2 sine arctangent of x times the cosine of arctangent of x. And using what I know here, I can get that this is just if I multiply, I get 2x over 1 plus x squared. Okay, but I'll use different techniques. I use computation directly to multiply here cosine times the sine. So I'm gonna get, with this 2 I get 2x, and this one is the square root of 1 plus x squared times the square root of 1 plus x squared is just 1 over 1 plus x squared, and therefore I have this result. Okay, now if I go back now and I see that I have 2 arctangent of 1/2 minus arctangent 1 over 7. So if I call this one here, so if I call this angle alpha and this is beta, now I can use the cosine of alpha minus beta as cosine alpha times cosine beta plus sine alpha sine beta. Okay, so if I use that, so I will have so alpha minus beta is this quantity here. So I'm gonna use this one here and come back to the I will take the cosine, the inverse cosine or the arcosine to get this angle here, its value, which is gonna be pi over 4. Okay, so here I have the cosine of alpha. So here, so now, so it's gonna give me the cosine of 2 arctangent 1/2 times the cosine of arctangent 1 over 7 plus the sine of 2 arctangent 1/2 times the sine of arctangent 1 over 7. Okay, so now I'm going to use my previous results here. The cosine of 2 arctangents is 1 minus x squared over 1 plus x squared. So the x here is 1/2. So this one will give me 1 minus 1/2 squared over 1 plus 1/2 squared times the cosine of 1 over 7. Okay, so this one will give me just 1 over the square root of 1 plus 1 over 7 squared plus. So here I'm going to use these two here. So it's going to be 2 over 1 plus 1/2 squared. Okay, using this fact here, this fact here. Okay, so it's going to be 2 times 1 over 2, sorry. And I'm going to get the sine of arctangent of 1 over 7. So it's going to be 1 over 7 everything over 1 plus 1 over 7 squared. Okay, let's use some algebra. So here I'm going to have 3 over 4 over 5 over 3 over 4 over 5 over 4, and this one will give me 7 over the square root of 50 plus this one will go, and I'm gonna have the 7 will go, so I'm gonna have 1 over 4. That means I'm gonna have 4 over 5 times the square root of 50. Okay, so I can simplify. I'm gonna get 3 times 7 plus 4 over 5 the square root of 50. Okay, so this one is gonna be 25. Yes, it's gonna be 25 over, so I'm gonna get the 5 from here. Square root of 50 is 5 square root of 2. So the square root of 5, no, the square root of 2 or 5 times the square root of 2 times 5 is going to be 25 square root of 2. This one will be 1 over square root of 2. Okay, so therefore the cosine of alpha minus beta is square root of 2 over 2. Okay, and since I have shown that this alpha minus beta is between 0 and pi over 2, note why I need this. Because here, the square root of 2 over 2, okay, so there are many angles. This one 2, but other angles would give me the same square root of 2 over 2. But since I'm here between 0 and pi over 2, so therefore if I take the arcosine, so I'm gonna have only one angle, which is this one. Okay, so therefore alpha minus beta is pi over 4. This is the only one, because I'm here, I'm in between 0 and pi over 2, and we have shown this result here. Okay, can just use that the fact that the arctangent is an increasing function, and is that 1 over 2 is bigger than 1 over 7. Okay, and therefore I have shown the result that I need. Okay, so I here for these results we have proven them. This one, the other ones like this one here, we have proven this result as well, and we know them from trigonometry. Therefore, this proves that this quantity is just pi over 4. Some people are suggesting complex analysis using that. Yes, that's a good idea too. Yes, we can get that too, but using pre-calculus, it's good for everyone. Other people may not know some calculus, complex analysis calculus, and using the argument of the complex numbers to get the result. Okay, so this is the solution. If you see any errors or mistakes, please let me know. Please like and share and subscribe if you want to. Thank you very much. I wish you a great day. Thank you again.